Whenever I see a problem like this and we know that we have 2 points and we need a third point that is equidistant from both points, it always makes me think of our perpendicular bisector theorem. If you recall, we went through and we showed that if we have 2 points and we find the perpendicular bisector of the segment that joins those 2 points, we found that any point anywhere on this line, up and down the whole thing, we found every single one of those points would be equidistant from both points. If you remember, we proved this using side angle side because we'd have the reflexive property for our segment in the center there, and then we know that we have 90-degree angles, and we have that other side. So we know that any point on the perpendicular bisector is going to be equidistant from the 2 points. So I'm first going to construct the perpendicular bisector of the segment joining A and B. So I'm going to draw my segment joining A and B, and then I'm going to find the midpoint. Well, the distance between A and B, it has a horizontal distance of 2, so the halfway mark would be 1, and it has a vertical distance of 8, so the halfway mark would be 4. So I'm going to go over 1 and up 4, and that's going to get me my midpoint. It looks like about right there. Then I know that I need the perpendicular bisector. Well, I know I've bisected that segment because I've found the midpoint, but I need to find a line perpendicular. So just to review, we always find the slope in order to make sure we have perpendicular lines. In this case, my slope goes up 4 over 1, or maybe you want to say it goes up 8 over 2, which still reduces to 4 over 1. Well, then my perpendicular slope has to be negative, and the reciprocal. Well, the reciprocal of 4 over 1 is 1 over 4. So from the point that I have there, I'm going to go down 1 and over 4, and I'm going to repeat that process. So if I go down 1 and over 4, I know that that point is equidistant from A and B because it's on the perpendicular bisector. And I can go down 1 and over 4 again, and that point is equidistant. And then I can go down 1 and over 4 again. And I'm going to have to repeat that process in order to get back down to the x-axis. I'm going to have to repeat that process 4 times. So I repeat it 4 times because I can go 1 more and then I get down to the x-axis. So I need to find the coordinates for that point clear out there. Well, if I repeated that 4 times, I went down 4 times because my slope is 1 over 4. I went down 4 times, so I basically multiplied the slope times 4. I'm going to go down 4 times, and I'm going to go over 16 times. So I know that to get back to the x-axis, I have to walk down 4 times, and each time I go over 4 for a total of going over 16. Then I know that this point right here that gets me back to the x-axis has to be the point over 16 up 0. So the point on the x-axis that I know is equidistant from A and B is the point 16, 0. And I would have that line there. That would be my perpendicular bisector.